Hey, hello, Internet. Hey, let me turn down my music. I gotta turn down my music. Internet, hello. Good evening. Happy day. My name is Joey, and if you're here, then you're here where everyone loves math. This is our live show where we do some math problems. So we're going to get right into it today. Now, there are several ways that you can ask a question to get worked on during our live show here. One way is with this right down there, the Everyone Loves Math hotline. You can text, snap a photo, video, send it to that hotline. You can post a question to the Twitch chat, or you can go on the Everyone Loves Math message boards in between shows. And we'll talk about all that in a little bit later. But I did want to take care of two questions right off the bat. I had two questions come in on the hotline earlier, and I thought that'd be a good use of our time, man. Look at us, rational functions. So let me set the stage for you beautiful people. Rational functions, you're going to be looking at these in like Algebra 2, pre-calculus, college algebra, that kind of stuff. And so this problem is one where they give you a graph, and I happen to know that like you could zoom in on this graph and see some more stuff, but they give you this graph, and then they're asking you questions about up here. Let me just highlight where they're asking questions. Up here, they're asking about what is the domain and range, what are the intercepts, horizontal, vertical, and oblique asymptotes. So one thing to know is it's a little hard to tell by looking at this. So I'm going to guess at a couple of these numbers. But if I was able to zoom in, I'd be able to tell like super carefully. All right. So the other piece of this is I think maybe we'll probably just talk about these answers. I might not write these out if it doesn't require any work. All right, let's check it out. So domain and range. Okay, so we'll do the domain first. If we're looking at the domain, then I want to see, are there any places where things go bad? And I notice that there are two vertical asymptotes right here, somewhere on the negative side. I believe that is -6. And over here on the positive side, which I also believe to be +6 because I like zoomed in and counted the little notches. So as far as our domain is concerned, x is not allowed to be either 6 or -6. So I don't know. I guess I am ended up writing stuff. So for the domain, I would say for this one is all x's such that x is not -6 and x is not 6. So that would be our answer for domain. All right. They ask about the range. So let's talk range. So range is the same except with the y values. So if I look at this thing, let's just take a look here. So negative y values, those are included because stuff's happening here. 0, it looks like 0 is included. Positive y values, these are included. It actually looks like the only place where y values are not included is on that horizontal asymptote. And when I look really carefully, it looks to me like that horizontal asymptote is the line y equals 1. So I'm going to say all y's where y is not 1. Now again, if I could zoom in on this, I would. And if I zoomed in and saw that that was actually 1.5 or something, I'd change my answer. Okay, there's our domain. All right, next up, the intercepts. So that would be part B. So part B, the x and y intercepts. So let's take a look here. I'm going to make a little red highlighter. Yeah, I'll do green on this graph. So if we're going to do intercepts, let's see. We'll look at the x-intercept first. Oh, it doesn't actually matter. It looks to me like the origin right there at 0, 0, that looks to me to be the x-intercept and the y-intercept. The origin, 0, 0, is the only place that that graph touches the x-axis, and it's the only place that graph touches the y-axis. So I would say the intercepts, I would say the x-intercept is the same as the y-intercept, and that's the point 0, 0. All right. So Stove, for the range, you might need to zoom in and see, is this right here? Is that a 1 or not? Is the horizontal asymptote at 1, or is it at like 2 or something? You could tell if you clicked on this and zoomed in. All right, and if you see something, let me know. Okay, so you said yes, 1. Let's see. Okay, if I look at this carefully, let me go back to this. So if I look at this thing extra careful, I'm going to zoom in a couple times, okay? Oh, I didn't even know I could do that. Oh my God. I zoomed in too many times. All right, so if I zoom in a whole bunch of times, let's look here. Oh, I guess there is... okay, I guess there is more stuff to put in. So, Stove, when we're looking at this, one place that I didn't notice is it actually looks like there's nothing happening in between 0 and 1. Look at that. So in that space in between 0 and 1, this function is also not happening. So that would not be in the range. So let me go back and fix that. I guess the only way we can tell is by looking at the graph. But let's go back and fix that. So what do we want to say here? Well, what we would want to say is we would want to go do all the y's that are less than or equal to 0, and then all of the y's that are greater than 1. I think we would have to put that in for our range. All right, I'm going to go back up and look at it. So that says all the y's less than or equal to 0 combined with all the y's greater than 1. Because, yeah, if y is bigger than 1, then it's covered on this top graph. If y is 0 or smaller, it's covered on this bottom graph. So, yeah, I guess that piece is missing. And we could have been able to tell that by zooming in. Yep, that's my B. Okay. So we did the intercepts. Now let's talk about... Oh, we already did talk about the asymptotes. So the horizontal asymptote is... There you go. Horizontal asymptote is that line y equals 1. We got that. The vertical asymptotes, there are 2. And again, zoom in to double check, but it looks like x equals -6 and x equals +6 are the vertical asymptotes. Those are the two places where something bad happens, right? Probably those are the two places that make the denominator 0. And then there are no oblique asymptotes. There's none that are at a slant. We also call those slant asymptotes. All right. Stove, are you cool with all that? We can move on to the next one, or if you have a question, we can tackle this one before we move on. All right. Cool. X and Y intercepts are wrong. Okay. You tell me. Let's zoom. We got to zoom in here. Okay. So this is me zooming in on the graph. All right. So as far as the y-intercept, 0, 0 sure as heck looks like a y-intercept to me. If you can zoom in and find, like, I don't know if this graph touches the y-axis anywhere around here, but you would have to zoom in really far to be able to tell that. Okay. All right. You sent me into the hotline. Let me check the hotline there, Stove. Let's look here. Doodly doo. Stove just sent it. Doodly doo. Let's see here. All right. It's in the tubes. There it is. All right. Well, I'm zooming in. Yo, they're not... Seriously? They're not accepting 0, 0? Dude, that's messed up. And they don't give us the function, right? They just give us the graph. They don't give us the formula for the function. So I would put that as a question mark, Stove, and that would be a good question. Is where the heck, I don't know, or do you want to tell me what does the website say that the correct intercepts are, and then we can look at it and tell. Yeah, I don't know. I would say something funky is happening here. Yeah, 0 0 in it. Right. Okay. Mm-hmm. Did you like forget? I don't know. Dude, I don't know. Sometimes those programs are so picky. All right. So, but for the rest of this, we did answer, right? We already did at least we got that part. Yeah, send it to your teacher. So we did the part about the horizontal asymptotes and the vertical asymptotes. We got those. So all that is going to be groovy. All right. So Stove, while you're catching up on that, I'm gonna go to the question number 2 that you submitted, and I think I'm gonna try to make that. Yeah, I'm gonna try to make that a little bit bigger now. All right, there we go. Okay. All right. Let's see. Yeah, Stove, let me know when you're set. When you're ready, I'm ready. We'll knock it out together. All right. All right, Stove. So we're on our next question about rational functions, and I know this because Stove and I were talking earlier. We know this is what an oblique asymptote looks like. So we'll talk a little bit about that. But first, talking about domain and range. Let me do this. I'm going to make another line here. I had this idea to talk about domain and range by looking at this line. All right, so check this out. So the reason why I made this line is I'm going to see this. Ooh, of course I do all that, and then the thing that I move is everything but the line. All right, there's the line. All right, I'm going to put the line on the graph and make sure that as I move it from left to right, I touch all the X's. So over here, we're good because we're touching the blue line, right? And that blue line is going to continue up that way forever. All right, we're touching blue, 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 blue. Now, this down here looks like maybe some vertical asymptote action. So it looks like maybe if I look carefully, what is this? The y-axis looks like it's red. So I think there is a vertical asymptote right here at x equals 0, so that's bad. Picking up on the positive side of x, I think this is telling us that the function is way up there. And then as we continue to trace out to the right, we're looking good. So for the domain, I think the only bad value is x equal to 0. All right, so when we go and write the domain, we should write x cannot be equal to 0. All right, that's for our domain. All right, now if we look at the range, I'm going to use my horizontal line. I'm going to bring this up here. So we're looking at the y values. So when y is negative, that's definitely covered because you can tell those blue arrows pointing down are going to hit all these negative y values down here. As y goes up to 0, yep, the graph exists there. And as we go up positive, the graph exists there. If we look in the vertical sense, there is nowhere vertically where this function is not happening. So the range for this function, let's just put it underneath. So the range, I need to write darker. The range for this function would be all real numbers. Because there are no y values that are not considered by this graph. Every y value, it appears somewhere. Okay, so now we are ready for intercepts. So good news, the x-intercepts are literally labeled on the graph for us, right? The x-intercepts are -5, 0 and +5, 0. Like they're on the graph. And those are the only two places where the function touches the x-axis. So those are the two x-intercepts. Okay? When it comes time for y-intercepts, notice that the y-intercepts, there is a, there's a vertical asymptote right here. This function never touches the y-axis. So there is no y-intercept because the function never touches the y-axis. So the x-intercepts are labeled and there is no y-intercept. Okay, continuing on with this problem, horizontal asymptotes, there's none of those. Because what happens with this function, I'll even go to blue marker, you can tell this graph continues to grow that way. This graph continues to grow off the page that way. These are not going to level out and approach some number. So there would be no horizontal asymptotes. Let's see. The vertical asymptote would be at x equals 0. So we did talk about that. So that's if you look really carefully, there's that vertical dotted line at x equals 0. And then oblique asymptotes. So they want the equation of the oblique asymptote. So here's the thing that you need to know. Oblique asymptotes look like slanted lines. So good news. The formula is a slanted line. It's y equals mx plus b. Like that's the formula for oblique asymptotes. So all we have to do is look at this thing, look at this red dotted line. That is, let me use my little laser pointer right here. We're going to use that red dotted line. Can I come up with the equation of that line? Well, the answer is yes. In order to come up with the equation of that line, I need the slope and an intercept. So in this problem, the slope, oh boy. Well, the slope of that line, let's see, they're telling us this point, -2, 2, -6. So that means we would go, it looks like 0, 0 is also on this graph. So from 0, 0, we would go down 6 over 2. Down 6 over 2. That would be -6 over 2 for the slope. But wait a minute, -6 over 2, that's just -3. So it would be y equals -3x and then really plus 0. Because the red line, that red diagonal line, the y-intercept is 0. So the equation of that line would be y equals 3x plus 0. And of course, no one ever says plus 0. So that would be the equation of the oblique asymptote. And Stove, even though that sounds crazy, that's something you could have done a long time ago because that's really just finding the equation of a line. So don't worry about all this, rational function stuff. Sometimes the equation of a line is just the equation of a line. Know what I'm saying? All right. So those were the two questions from T Stoves. So we got those taken care of. T Stove, you got another question for us, or are we good? It doesn't like what answer? I don't like your answer. You mean the y equals -3x? Okay. So here's what we can do. Can you zoom into this graph? And I know that 1 point on the graph is 2 comma negative 6. Can you give me another point on that dotted line? Was there something I missed? So does that dotted line go through 0, 0? And that's not 2 comma negative 8, right? It's 2 comma negative 6. Something's up there. It wanted, but that's what we wrote. We wrote y equals negative 3x. They wanted parentheses around it. That's ridiculous. Take a picture, send it in. Yeah. I don't know why there with the parentheses. Yeah, there isn't there isn't a mathematical reason why that would have parentheses. I can't tell you why. Yeah. Get him. Get him, Stove. That's what I say. Attack. You tell him. He said my favorite math teacher. They love it when you say that. My favorite math teacher and I were talking about this problem, and we'd like you to give this another look. Oh, you are sending a problem. Okay. All right, so we got another problem coming from the hotline. All right. I love doing problems. I love doing problems in college algebra. In college algebra and pre-calculus, you love it so much. Okay, here we go. Oh, come on. You gave me one of these again. All right. Okay, we'll look at it. Okay. Gosh darn it. Here we go. So we've got this function. We're going to start over here. F of x equals, and it's a rational function. They give you a fraction. All right. And we got 1 over x plus 6 squared. All right. Stove, we're probably good with this one. All right, so we got 1 over x plus 6 squared. And what they want us to do is talk about the graph. They want to talk about the domain, range, and all the asymptotes. Okay? So let's talk about the graph, the domain, range, and all the asymptotes. All right. So first things first. Let's analyze this bad boy. All right. There's a couple things we can say about this. Actually, there's quite a few things we can say just by looking at this. Okay. So here is, and the other cool thing is if you understand this, not only can you get this stuff right by looking at it, but we don't have to do much calculation, at least at the start, much at all. So let's talk. So for example, the domain, right? We can talk about the domain pretty easily, because I can look at that thing and know that if you have an x plus 6 in the denominator, then it would be real bad to put negative 6 in for x. If x was negative 6, then you would have negative 6 plus 6. You would have a 0 squared. 0 in the denominator. How dare you? You can't put zeros in the denominator. So we would say something about the domain like it's the set of all x's such that x is not negative 6. All right. And I know what the question asks. The question asks us to match the graph, but we need to do a little bit of work before we're going to match the graph. Most of the time, I can't really tell the range by looking at a function. I mean, most of the time I got to do a little bit more work, but in this particular problem, I think we're good. I think we could actually tell. And the reason why I'm thinking about it is if we think about this fraction, this is a fraction where it's going to be a 1 on top, and then the bottom is something squared. So I know that 1, that's a positive number, and something squared is a positive number. So I think the range is going to be all positive y's. I don't think you can get any negative y's out of this, but I normally wait to see the graph on that. Okay? All right, let's talk about asymptotes. So vertical asymptotes kind of hang around with the domain, because let's talk -6, right? So when x is -6, that makes the denominator 0. And we would have 1 divided by 0. We would legit have a number divided by 0. That's bad. There is a vertical asymptote as the line x equals -6 for this problem. -6 makes the denominator irreparably bad. All right, horizontal asymptote time. So horizontal asymptote, remember, has nothing to do with vertical asymptotes. Horizontal asymptote is what happens for very large and very small values of x. So let's just pick a very large value of x. What would we have? Let's pick like 1,000,000. This would be 1 over 1,000,006 squared. Right? That would be a number incredibly close to 0. So this thing has a horizontal asymptote at y equals 0. When I pick large values of x, I'm going to have 1 divided by a huge number. And 1 divided by a huge number, very close to 0. Okay, let's see. Finally, there are no oblique asymptotes. So, I mean, I can say that. So there are no oblique asymptotes. All right. And then intercepts. Let's talk intercepts for a second. So for for a y-intercept, we can put 0 in for x. If I put 0 in for x, that'd be 0 plus 6. That'd be 6 squared, 36. So it'd be 1 over 36. So one of the intercepts we know is when x equals 0, y equals 1 over 36. This is the y-intercept. All right, as far as the x-intercepts, I would want to maybe look at that. Well, let's talk about this, actually. We can answer this question. Sometimes we can and sometimes we can't. Let's look at this thing. So, stove x-intercepts is where y equals 0. And y is 0 when this fraction is 0. And I'm going to tell you right now, this fraction will never be 0. 1 divided by a number, if that number is really big, can get close to 0, right? 1 divided by 1,000,000,000 is close to 0, but 1 divided by a number will never be 0. So here's what we know. If the y can never be 0, this thing has no x-intercepts. Okay, and now finally its graph. Whoops. I was going to scroll around. All right, so finally let's talk about its graph. So we've done like a little bit of the work. Notice that, like, we've done a lot of talking, but I haven't had to pick up my pen that much except to write down the answer. So let's talk about, like, what do we know about this graph, right? 0, 1 over 36, that's the y-intercept. Super close to the axis. There are no x-intercepts, no oblique asymptotes. What else do we know? There's a vertical asymptote at x equals -6. So I'm going to go over here where -6 could be, and I'm going to put a vertical asymptote at x equals -6. There is a horizontal asymptote at y equals 0. So maybe I'll use a different color so that it shows up, but I'm going to put a horizontal asymptote here at y equals 0. And then after that, that's where you just kind of match it, or we can go to Desmos and graph it to see what it looks like, right? So if I'm looking at this thing, I mean, my guess, if I had to guess, would be this thing like does this, right? It like approaches its asymptotes here. But we can always plug in a couple more numbers to tell, okay? But for us, for tonight, Maybe we just go to Desmos. Let's go to Desmos and see. There we go. I'm going to go to Desmos and try this out. Let's see. Where is my Desmos? I got to find my Desmos. Give me just a second here. Do-do-do-do. Do-do-do-do-do-do. There we go. All right, so in this thing, I'm going to put y equals, make it a fraction. I'm going to do 1 over x plus 6 parentheses squared. And we can also practice getting that in a graphing calculator. So if we look at this thing so far this matches what we've said. So I definitely feel like there's a vertical asymptote happening. So let's show that off. If I graph the line x equals 6, negative 6, and I can hard click on that and make it a dotted line, that definitely looks like a vertical asymptote to me. So I'm feeling that. My horizontal asymptote at y equals 0, again, I can make that a dotted line. I'm feeling that right there. And then by looking at this, I can tell that sure enough, the range of this function are all of the y's greater than 0, because this graph only exists when y is positive. Nothing happens for negative values of y. All right, so I think by now we've answered all parts of that question. That is a multi-part question. Okie dokes. So, Stove, I'm going to let you kind of look and see what else you want to ask. For other folks, I started the show tonight without kind of talking much about who I am and what I do. So let me do that. Hey, good evening. I'm Joey. This is Everyone Loves Math. So what do I do here? So I'm the founder of Everyone Loves Math. I've been a math teacher for a really long time. I've done a bunch of other stuff in education as well. And made this website to be able to talk about math with grades like 5 through, Calculus 1. So a couple things to point out about my website. I offer tutoring. So if you click on the link, and this is everyonelovesmath.com, you can click on my tutoring link and it opens up my availability for the next 2 months. So you can go in and sign up for tutoring that way. You're watching Everyone Loves Math live. This is information on my site. So this is a show that I do Monday through Thursday at 9 o'clock, where you bring any math questions you have. You can either drop them in Twitch chat, put them in the Everyone Loves Math hotline that's scrolling at the bottom of the screen, or you can join the Everyone Loves Math message boards and post a question that way. All kinds of ways to interact with the stuff. I love taking questions from math students and helping folks out. And when there aren't questions, I tend to look at Reddit. So what's up, Foster? So I am no longer a teacher. I am doing tutoring full time. But here's what I can tell you. I taught high school math, and I taught high school math for about 20 years. Everything from pre-algebra all the way up to AP calculus. I have trained dozens of teachers to teach math, and I've written curriculum. I've done all kinds of stuff. So I'm kind of a fan of math. So if there is ever any kind of math question you have, this is a spot where you can ask it, and I'm here. All right. So Stove, let me see what you're asking here. I'm gonna pull up my hotline. Stove asked a couple of questions. I'm pulling them up. Let's see. Oh my goodness, it won't let me zoom in. Okay, there we go. The function. This is. Oh boy. All right. Stove, they're asking you questions in a really dumb way. I really don't like this. All right, Stove, here we go. Let's see. Right. I see you, Foster. let's go to the board. Let's go and talk about this question here. All right, so Stove is asking about, we got this function. This is on, I don't like writing in I don't like writing in red. All right, so let us do big F of x. All right, so this one's coming in off the hotline from Stove. Is negative 1 over x squared plus 4x plus 4. All right. Boom, boom, boom. Okay. And what they want us to do is they want us to compare this to the graph of 1 over x squared. All right, so they want us to take this thing and compare it to, I'm just going to write it off to the side. Compare it to 1 over x squared. And in order for us to compare it to 1 over x squared, we need to factor the denominator. And because I can't make this the subject of our business here, this is x plus 2 times x plus 2. 2 times 2 is 4. 2 plus 2 is 4. And so I'm actually going to rewrite big F of x. And I can rewrite it as negative 1 over x plus 2 squared. All right. So for everybody watching, the question asks, how does this thing compare? Now I'm going to draw the little connection here. How does big F of x compare to 1 over x squared? And if you look, they look kind of similar, right? There's kind of a 1 on top, and I see kind of an x squared on the bottom. But what we can definitely say is that big F of x has this negative here. That's a difference. And it has this plus 2. That's a difference. And so in order to get this question right, we need to talk about transformations, or at least this is a transformation problem. So what I'm going to do is I'm going to give the answers, and I'm going to tell you where to look it up to see more of this. Because for at least this one shouldn't surprise you. That if we hit a function with a negative, this would be a vertical flip. Hitting a function with a negative flips something vertically. So this is a flip vertical, or a vertical flip, or a reflection in the vertical direction, however they want to call it. That is a vertical flip. So if you think about an x squared being a smiley face and a negative x squared being a frowny face, there's your flip. Okay. The plus 2. So this one, we have done these rules for the last few years. It looks different though when it's a rational function, but it still works the same. So when there's a plus inside with the x, this is a horizontal translation, and it's to the left 2 units. So this is a shift, a horizontal shift, left 2 units. Okay, and then I think what we'll do is, Stove, I think we'll make this the last question for tonight, unless another one comes in on the hotline. But I want to look in Desmos for this thing, and let's talk about what this thing looks like in Desmos. So I'm going to go back to Desmos. Oh, look, it's my website again. Why don't everybody go to it? All right, there's Desmos. I'm going to clear everything out, and let's look at this thing again, okay? And of course, in order to look at it again, I have to remember what the heck it's called. Oh, there it is. Negative 1 over x plus 2 squared. Okay, so the first thing I'm going to graph, just so that we can see what's happening in this problem, is I'm going to graph 1 over x squared. All right, so there's the graph of 1 over x squared. And now let's see what happens if we graph the same thing, except I'll put a negative. So we'll do negative 1 over x squared. So notice what that did, right? The negative flipped the thing upside down. So we have the positive 1 over x squared, and then we have the negative 1 over x squared. So that's where that vertical flip happens. hitting a function with a negative flips it upside down. All right, so now let me put in the next step. I'm going to put it in as equation 3, negative 1 over x plus, 2 squared. All right, so here's where you got to take a look kind of carefully. These two functions, the blue one and the red one, they look awfully similar. So if we just look, here's the red one again. Remember, that was the upside down 1 over x squared. And then if I just put a plus 2 on the inside, notice that they have the exact same shape, but the blue one is 2 units to the left of the red one. And you can pick a point, any point, and move 2 units to the left, and it hooks up on that other graph. So sure enough, this thing is flipped upside down and moved 2 units to the left. All right, that is our answer for that. Clap. Please clap. All right. I'm going to call it there for tonight. I'm actually, it's 9:41. Normally we go until 10. I'm going to go just a little bit shorter tonight. But if you have questions, get them in on the the Everyone Loves Math hotline. Ask them in the Twitch chat. Find me on everyonelovesmath.com and let me make all of your mathematical dreams come true. That would be just fantastic. That having been said, everybody have a fantastic night, and we'll see you back here 9 o'clock to answer all of your questions. All right, Stove, you too. Have a great night.